The third tourist has a pretty swanky marina. And what do swanky marinas need? Well, a matching swanky guest services building, of course. This is the building in its latest iteration. It's not finished, we need to add more detailing, but this will come in time. In the meanwhile, the essential shape of the building is done. But how did we get to this point? In this video, I'm going to talk you through how we make our modular buildings, from how we take many mesh layouts to just a few meshes, and then how we light the space using adaptive probe volumes, or APV for short. The finished room is looking pretty much as beautiful as we could hope for. It's using a combination of baked APVs along with HDRP volume effects such as screen space global illumination. HDRP stands for High Definition Render Pipeline, and it's one of 3 render pipelines provided by our game engine Unity. On screen right now, you can see that we are also using ray-marched screen space global illumination, or SSGI for short. SSGI using ray marching is cheaper than full ray tracing, and it still looks pretty awesome. But if we wanted to, we could use full-on ray tracing. Is that an option you'd like to see in the game settings? Let me know in the comments. It's worth noting that although SSGI is literally a screen space effect, it does coexist and take advantage of the baked APVs. The only other thing worth mentioning here is that there's also some screen space ambient occlusion turned on, which is giving us those nifty shadows under the furniture. Let's make the individual APV probes visible, and we can see they are scattered throughout the scene at regular intervals. In this case, the probes all look pretty much the same, as this is a fairly evenly lit scene. Next, we're going to start turning things off so you can see what a huge impact high performance lighting has on what is otherwise a really straightforward low poly scene. Before we do that, let me draw your attention to how the sunlight is gently bouncing around near the windows. Gorgeous, isn't it? If we turn off SSGI, you can see how that immediately disappears. The scene is now only receiving indirect lighting from the APVs. Even without any other processing, this is still giving a really good indirect lighting effect. For example, look at the ceiling near the windows to see how the light is bouncing back up and making it brighter. So now we'll delete the baked APV lighting. See how everything now looks flat? To be honest, in this particular well-lit sunny environment, it still looks quite pretty, but if you had a more regular room with solid walls on all sides, the lighting would look really flat and far more basic. We'll return back to lighting in a moment. But next, let's take a look at how a modular building like this is created and then processed. If we just pop into the prefab editor, we'll look at how this building was made a bit more closely. First, let's hide the roof so we can see inside better. The fact that I can easily do that is because we assembled the buildings in layers. We can see that the whole thing is made from tiled modular assets. This is incredibly convenient as it means we can select from a large range of modular pieces, and in combination with using Snap to Grid, we can expect them to mostly line up and fit together. You can think of these modular pieces like Lego bricks that we can fit together in any way we like. Working like this would be fine if we were only working with very small levels, but when you have a small open world like the third tourist, with many dozens of buildings made up from hundreds or thousands of these pieces, it just doesn't work out from the perspective of performance. You can see if we look at the hierarchy, there could easily be 100 pieces in this one little building, and this is a fairly basic structure. There's no detailing and barely any props. So why is this a problem? It's to do with how the game engine sends instructions to the GPU to render the graphics. By having lots of separate meshes like this, the CPU has the work of saying, hey, take this little mesh with this material and send it to the GPU to draw. It then has to do that for each and every module piece. These are called draw calls, and when they start adding up into the thousands, this can seriously kill the game's performance, with frame rates dropping into the single digits or less. There's probably a better way to deal with this problem, but this is our first 3D game, so we don't know all the best tricks. Instead, the solution we're going with is custom tooling we've written that takes an assembled model and merges all the individual pieces into a single mesh. A basic mesh can only be associated with a single material, which of course is no good because overall the model will invariably end up using several different materials. The solution to this problem is to create a single mesh which has submeshes. And it's by having these submeshes that lets us associate a different material to different parts of the overall model. Our tooling is doing quite a few things to process the model. For example, it's gathering a list of all the unique materials and then merging the separate meshes together into a submesh grouped by materials. The point of doing this is that by using what is effectively a single mesh means that we can turn hundreds or thousands of draw calls into just one draw call. Now that's pretty convenient. The tool takes a few minutes to run. The actual mesh merging part of the process is almost instantaneous, so most of this delay is being caused by a decimation processor. The idea with decimation is to reduce the number of vertices and triangles in a mesh. This increases performance by having a simplified version of the model. We've decided to apply a small amount of decimation even to the high detail versions of the model, as making something use 90% of the original triangle count makes no perceptible difference to the final model, but does improve the performance a little bit. We apply much stronger decimation to the low detail version, which is only intended to be viewed at a distance. Viewed up close, it really damages the integrity of the model, but when viewed from afar, it does all it needs to do. One problem we ran into when merging everything together related to the glass windows. The problem is that even though the material can be transparent, meaning that we can look through it, the mesh itself needs to be configured to either cast a shadow or not. With most parts of a model, e.g. things like our walls and roofs, these meshes need to cast a shadow. The problem here though is that you can only set the shadow property on a mesh by mesh basis. You can't just say, hey, I want this submesh to cast no shadow. It's all or nothing. So returning back to things like windows presents a problem, as by merging them into the single model, it means the glass looks transparent, but actually ends up casting a shadow, which of course is incorrect. If you're following along closely and watching the details of this video, you may have already noticed that the solution to this was to add a separate mesh. So anything that is supposed to be glass gets added to this second separate mesh. That way we can independently turn off the shadow of that single mesh and have light coming through a window, just like you'd expect it to. At this point, we thought we were on a home run, having swatted all these little bugs, but then we got stung with an APV behavior that we weren't expecting. Let's rebake these APVs. I'll speed up this part of the video as it takes a minute or so to render out the probes. Okay, now it's done and we can immediately see that something has gone badly wrong. The probes have turned everything into a complete mess. It took us a while to figure this one out, as the problem is not immediately obvious. What's happening is that the APV bake is not respecting the no shadow property of a mesh. It means the probes think they're in an unlit dark room. Combined with the direct lighting from the sun that continues to stream through the windows as it should, we end up with this completely broken high contrast version of the very dark indirect lighting and bright direct lighting. We didn't know if this was a bug or a configuration problem on our part. It didn't seem right to us, so we reached out to the folks on the Unity forum to clarify. Now, a shout out to Unity staff member Pima Malling, as they are always so quick to respond on the HDRP APV thread. They came up with a few suggestions, and the answer was to turn off the setting where the glass meshes contribute to global illumination. This means that they can still receive lighting, but they never occlude anything. At time of recording, although we have this workaround, it's not clear if this is actually a bug in HDRP, so Unity is going to see if they can reproduce it. So there you have it. That's a brief overview of how we created the Marina Guest Services building. It's also an insight into the spurious and complex day-to-day problems we're encountering as game developers. It's not just about writing code or making models. A huge part of development is learning the technology at a very deep level. Thanks for watching. Bye!